In today's class, we will try to discuss about the kinematic graphs. So what is meant by this kinematics? Kinematics is a branch of physics which deals with the motion of a body without going to the cause of the motion. Cause of the motion means what? Without discussing or without dealing with the force, okay, as force is the cause of the motion, right? Now in this kinematics we have already learned about a distance time graph, okay. So but we will have to discuss in this video we will have to discuss more in details about those different types of distance time graph, velocity time graph and acceleration time graphs in details, okay. Before discussing about those different types of distance time graph, let's see what can be obtained from this distance time graph, and we will try to see into those different graphs, and I will explain you details of these different observations that we obtain. For a distance time graph, the distance never decreases. When the object is stationary, the distance time graph will be horizontal. The gradient of the distance time graph is the instantaneous speed of the object. When I say instantaneous, means at that very instant the speed of the object, we call it that as instantaneous speed, okay. If the time duration is very small, then what happen, we will find that at that moment, right? And what is meant by this gradient? The gradient means it is nothing but it is the change in the distance with respect to the time. I'm talking about this distance time graph. So this distance, when we discuss about the drawing of graphs of this distance time, then what happen, distance will have to be drawn along y-axis while time will have to be drawn along x-axis, because time is independent variable and distance is dependent variable. So we need to draw always the dependent variable along y-axis while independent variable along x-axis. So that change in y with respect to change in x, we call it as gradient in mathematics. So for us also, y axis means what? Distance will be drawn along it, and along x-axis time has to be drawn. So your change in distance to the change in time, we call it that as gradient. So that gradient will give you the instantaneous speed of the object. For a straight line with positive acceleration, it means that the object is traveling at uniform speed. There is no straight line with negative gradient, as a distance of a moving object can never be decrease. For curves, it means that the object is traveling at non-uniform speed, okay, if it is curve. Now the details of these are similar to that of a distance time graph. In the case of displacement time graph, I mean, the only difference is that the distance is now replaced by displacement, and the instantaneous speed or the speed will now be displaced by velocity. One small difference is there, that there is a straight line with negative gradient in the case of displacement time graph. It means that the object is traveling at uniform velocity in the opposite direction, okay. So let's plunge into that of a distance time graph, and let's see what are the different distance time graph that can be drawn for this, okay, motion of an object. Now see, if the distance time graph is curved upward like this, curved upward, then what happen, it represents that the moving object is in acceleration. What type of acceleration? Acceleration can be positive, negative, okay. So this one is for positive acceleration. Positive acceleration means what? Velocity will keep on increasing, right? That portion is depicted by this curve from here to here, from the origin up to here, okay. And from here, this point up to this point, the graph seems to be a very straight line having with positive slope. When I say slope, that is the tangent of the angle, okay, made by this curve with the x-axis, this angle, I mean, got it? So what happened, this is the graph, that means this graph, the curve is a very straight line. Here the graph is a very straight line, so it represents that the body is moving with constant speed. Constant speed means with the same speed, uniform speed, you can say also. So from here, from this point to this point, that means during this time duration, the graph is a very straight line, which represents that the object is moving with constant speed. If the curve is curving downward like this, then it represents that it is slowing down. That means velocity decreases. Got it? And if it is a straight line parallel to the time axis or x-axis, then it represents that the body doesn't move. That means the body is at rest. Now let's see the different types of this distance time graph. So distance is denoted by x and it is drawn along y-axis, time along x-axis. Okay, if the graph is curved upward like this, as I said, that this is for positive acceleration. We know that acceleration is defined as rate of change of velocity. So change in velocity, final velocity vf minus initial velocity, we call it that the difference. Okay, final minus initial velocity, we call it that as change in velocity. Time duration, delta t, so rate of change of velocity. And in our lower class, we denoted that final velocity by v and initial velocity by u, time taken by small t. So we call it this as what, rate of change of velocity. Now if your final velocity is greater than the initial velocity, if your v is greater than your initial velocity, naturally this numerator will be positive. As time is not having any negative quantity, what happens if this numerator is positive, then your acceleration will be also positive, right? Your acceleration will be positive, I mean this acceleration. So if that such, that means what, final velocity what is more than the initial velocity, means what, the velocity or the speed of the object will keep on increasing. Then what happened, that type of the distance time graph for such motion where the velocity keep on increasing, you will have the distance time graph as curved upward like this. Yes. Next is what, let's see about that of a negative acceleration. If it is curved downward, okay, instead of curving upward, here what happened, you will see that the curve is downward like this. Got it? In such case, what happened, your acceleration will be what, negative. Why it is negative? Because your final velocity what happened, it decreases. Okay, final velocity decreases means when you compare with that of the initial velocity will be more, or rather you can say final velocity is less than the initial velocity. So in that case, what happened, this change in velocity will become negative, so your acceleration will be also what, negative. Now in the last case, when your acceleration is equal to 0, if acceleration is equal to 0, means what, your final velocity and initial velocity are same. If these two are same, final velocity and initial velocity are same, then what happen, your a will be equal to 0 by t, so it will be equal to 0. So acceleration a equal to 0 means what, this implies that your final velocity is always equal to the initial velocity. That means the body is moving with uniform speed, okay, with uniform motion, you can say. That means your speed, final speed and initial speed will remain same. That means the speed of the body never changes. If the speed of the body is not changing, then what happen, we said that acceleration is equal to 0. For such motion where acceleration is equal to 0 or uniform motion, then what happened, distance time graph will be a straight line like this. Got it? Yes. So let's see the details, more in details about the distance time graph with the actual graph like this. Okay, now distance is drawn along y-axis, time is drawn along x-axis. Now you will see that the graph from here to here, it is changing over the what, 3 hours. That means it is only 20. Now I will show you again. Okay, this is a very quick motion okay, of this graph is changing the animation, so you can read it by pausing the video. Okay, slope of the graph is steeper, okay, here in this case. Now I will come back again with this. Okay, I will show you again now with the speed time graph. Here the speed is how much? 6.6, so it will be a little bit up here like this, but in this case it is slope is very much more and the speed is also what, very more. It comes around 50 like that. Now when the speed is coming around 2.5 kilometer at this time, then it will come down here. Now at from 8 to 12 the speed is again small increase, 7.5 kilometer, so it will be little bit here like this. So this is a distance time graph and corresponding velocity time graph or a speed time graph on this right hand side. Okay, you just see. So this is what velocity changes from 20 to 70, so 50 change in velocity. You just see it. Okay, you can pause the video and you can check it. Okay, this is what time is 3, so it will be 3. Change in velocity is 20 minus 0 is 20, so it will be 66.6 something like that. Okay, kilometer per hour, I mean in the case of speed. So this is from here to here. Okay, from 8 to 12, from 8 to 12. Okay, now I will show you again. The time duration is for this graph is from 0 to 3, so time is 3 seconds, and the velocity, change in velocity, 20 minus 0 is 20. Now here is what change in velocity, 70 minus 20 is 50. Time is 3 to 4, that is only 1 second. And from here it is what, 80 to 70, that means 10 divided by 4 second, 4 hour. And in this what happened, the change in velocity is 30. Time is how much? 4. Got it? So like that, if you draw it with a distance time graph corresponding with that of a speed time graph on the right side, you will see like this. Okay, you can pause this video and you can check it, the calculation of the speed, okay, and the drawing of the speed versus time on the right graph. Okay, on the right side graph, I mean. Now let's go to the next one, that is a distance time graph. We are just repeating again whatever we have learned in a very quick manner. Okay, now let's see for the next one, that is when the body is at rest, what will be the nature of the distance time graph. If the body is at rest, then what happen, your distance from the origin will remain same irrespective of the time. At 1 second, for example, the distance from the origin, if the object is at rest, it will be having the same distance, this distance, okay, at different points, right? So what happened for a distance time graph, as I said, suppose if it is, let's take it that from the origin it is around say 8 meter. Okay, so in 1 second, this is 1 second, 2 second, 3 second, 4 second, 5 second, like that. If you take it, okay, in a equal what manner like this, then what happen, in 1 second also the distance from the origin is 8. In that 2 second also it is 8, the same height, I mean. Okay, in 3 second also same height, 4 also, 5 also. So if the distance remains same throughout the time, then we say that the object is at rest. So for that of the distance time graph of the body at rest, then what happened, the graph will be a straight line parallel to what, parallel to the x-axis. We say that speed for this that one speed can be obtained from this distance time graph by what, by the slope. What is meant by slope? Slope, as I told you that in the previous class, that it represents what, your slope is equal to tangent of the angle formed by that curve or graph with the x-axis. So your x-axis is also here parallel, so angle between this graph and the x-axis, that will be equal to 0. Tangent of 0 degree means what, it will be equal to 0. So your slope of this graph AB will be also equal to 0. So if your speed is equal to 0, that means the motion of the object represents what, it is at rest. So for a body at rest, okay, your distance time graph will be a straight line parallel to your time axis, right? Let's see. When a body is stationary, okay, we found that the graph was a straight line. No doubt that was also straight line but parallel to time axis. But when the body is moving with a constant speed or velocity, no doubt your distance time graph is a straight line, but it will not be parallel with the time axis. Rather, it will have some definite angle, okay, with the x-axis, right? So if the object is having some angle or slope, we can say, then what happen, it will represent what? Constant speed, okay, or velocity, we can say. Suppose if this angle is theta, that means the angle formed by the graph OA with the x-axis. If it is theta, then your slope, as I said, your slope is equal to what? Tangent of theta. So in this case, your tangent of theta is finite. So we say that this is having slope. So if it is having slope, this slope will give you nothing but the speed. Got it? Suppose if you want to find it out the slope of this, then you try to take a particular point on the graph OA and drop like this, perpendicular to the time axis. This will represent what? Your distance, okay. This will represent your time t. Got it? Rather, if you take it that this is your x final, origin your x initial, so it will be what? This x part will be equal to what? Your x final minus x0. x0 is here at the origin. Likewise, your t final is here, t initial is here, that is equal to 0. So your t final minus t initial, in this case what happened, your xf minus x0 will be equal to simply your xf, because your x0 is 0 at the origin, and your final time is tf minus t initial is 0. Got it? So what happened, your slope will be equal to what? Your slope will be equal to xf minus tf, like this, tf. Got it? So this distance divided by time, we call it that as what? Speed. So your slope, sorry, this was not what? X, rather I have to write it as what? Slope. Got it? So your slope is nothing but this slope is what? Your speed. We may denote it by this velocity, by v, and your v will be equal to what? Xf divided by tf, like this. Got it? But if the graph is, instead of distance, if you are having as displacement time graph, the only difference is that you need to change this distance by displacement, and this velocity by this speed by velocity with a direction. I mean speed with direction, we call it as what? Velocity, right? So if this, instead of distance, if it is displacement, then what happened, your slope will give you nothing but the velocity of that object, right? Now let's go to the next one, that is the distance time graph for comparing of two objects. Okay, now if you are given two graphs, okay, representing for the distance time graph for two objects, that means OA represents the distance time graph for an object A, and OB represents the distance time graph, okay, for an object D. Now if you want to find out that which of the object is moving with a higher speed, then you can easily find out by the slope. As I told you that the slope will give you the slope of the distance time graph will give you the speed of the object, right? So your theta here, the angle formed by this A is what? less here. Your theta of this A is less than that of the theta for this B, right? So as theta B is greater than that of theta A, then what happened? Naturally, the speed of the body B, okay, will be greater than the speed of the body A, right? Got it? So more slope means what? More angle formed by the graph with the x-axis. If this is more, then what happens? Speed of the object will be more. In our case, object B is having more speed than that of object A. It is also given here, okay? Now this is about that of the distance time graph of a moving object with increasing speed. If the speed keeps on increasing, then what happens? Distance covered per unit time will keep on increasing. So this is the distance time graph for that of the increasing speed. Now see, it is curved upward, as I told you that in the previous slide also. If it is curved upward, it will represent what? That of what? Positive acceleration. Positive acceleration means what? Final velocity is more than that of the initial velocity. So velocity somewhere here will be less and velocity somewhere here will be more, okay? In that case, what happened? The curve will be upward like this. I mean, the graph of the distance time graph will be curved upward. Suppose if you want to find out the instantaneous speed or instantaneous velocity in the case of the displacement, then what happened? You need to take a tangent, okay? Suppose if you want to find out the instantaneous speed at this particular time, then you need to draw a tangent onto this curve like this. Got it? A tangent. And this tangent will be having an angle here with the x-axis. The slope of this angle and the slope of this tangent will give you the instantaneous speed of this object at this particular time t. Say for example, if t represents the time at this moment, then what happened? It will give you the instantaneous speed by what? By the slope of this tangent. So what is this slope? Slope, as I told you, that it will be equal to tangent of this theta, right? Tangent of theta means what? If you draw a perpendicular from this, okay, at any point on this tangent, and if you drop down like this, then there is a right triangle here. You see, right triangle, okay? This we call it as distance. This base of this triangle, it will be known as what? Time. So you can easily find out the time from here to here like this, okay? What is the value here on the time axis? What is the value here on the time axis? The difference of that will give you the time duration, right? What is the value of x here? What is the value of x here? The difference of that two will give you nothing but the x. So x divided by time will give you nothing but the speed. And at what? At this particular moment, okay, at this particular time, that will give you the instantaneous speed. Instantaneous means at that instant or at that moment, we can say, right? So instantaneous speed of the body at a particular time will be given by what? Will be given by the tangent, okay, drawn at that point. And if you find out the slope of that tangent, then it will give you the instantaneous speed of that moving object at that particular moment. Got it? Yes, when a body is moving with decreasing speed, what happen? Or decreasing velocity, it will be curved downward like this. Got it? This we have already I have already told you. Now let's go to about the velocity time graph and what can be obtained from the velocity time graph. Let me give you the brief idea of this velocity time graph. Okay, first, when the object is stationary, what happens? It is a straight horizontal line at O. That means velocity is 0, means what? Your velocity will be 0, means your graph will be drawn with the time axis there at x-axis, okay? We will show you after this. When the object is undergoing uniform motion, it is a straight line, okay, where at v meter per second, this means where v is the velocity of the object. Now for a straight line with positive gradient means what? Distance, okay, keep on increasing. That means your velocity, change in velocity with respect to the change in time, we call it that as positive gradient. That means your acceleration will be positive. It means that the object is accelerating, okay. For a straight line with negative gradient, that means your acceleration is negative. Negative acceleration, we call it as what? Deceleration. It means that the object is what? Decelerating. For curves, it means that the acceleration of the object is changing. If the velocity time graph is not a straight line, rather a curve, then what happens? It means that the acceleration of the object is changing. Changing means what? You're accelerating, or your what? Decelerating is also changing. But in this case of changing, if it is curved, then it is not uniform, I mean, okay. It may increase or it may decrease, or it may be at constant, okay, depending upon the nature of the curve, whether it is curved upward, whether it is curved, okay, downward, depends on it. The area under the graph is nothing but it will give you numerically the change in the displacement of the object. Got it? So let's see those different graphs. Now you will see here the velocity time graph for different type of motions. Now if the graph, velocity time graph, is a straight line like this, having positive slope, okay, then it represents what? The object is accelerating. But the slope is very small, so what happens? It accelerates slowly. That means your acceleration of this object is very small. If the slope, okay, by knowing this theta angle, we can also find out the slope, okay. More the angle, more will be the slope. So angle is small here, so what happens? Your acceleration will be small. If the graph is a very straight line like this, and if it is very steep, then what happens? Your angle that is formed with the x-axis, let me draw it here. So with the x-axis somewhere here, this graph and this angle is greater than the previous angle. Let's make it this as first, okay. So angle 1 is very small, where angle 2 is more. So what happened? The graph, which will represent a straight line, as it is steeper, angle will be more. Angle more means what? Acceleration will be also more. That means the object quickly accelerates, okay. If it is a straight line parallel to the time axis, then it means what? Velocity of the object or speed of the object remains same. Remains same means the nature of the motion is steady, okay. Or you can say that the motion of the object is very smooth, or you can say the speed is uniform. Got it? If it is, the graph is straight line, but if it is coming downward like this, then we say that it is having what? Negative what? Slope. So the angle here that is formed with the x-axis, it is obtuse. See, the angle is obtuse, greater than 90 degree. So tangent of more than 90 degree or obtuse angle becomes negative. So we say that tangent of that angle, if it is negative, then we say we are having what? Negative slope. And so it is very much steep. So what happened? Your velocity decreases very rapidly. So it slows down rapidly. So there is a large deceleration. Got it? Here. And if it is here like this, parallel to the time axis, then it represents what? The velocity of the body is 0. That means the body is what? At rest. From this time to this time, the body is at rest, or the body is stationary. Now here the graph is again a straight line. It is in the negative velocity. So what happened? It is what? We can say that the motion of the object, it increases its speed in the opposite direction. And if it is parallel to the time axis again like this, then it represents what? It represents the steady motion of the object. That means the object moves with a uniform speed, but in the opposite direction. Got it? Yes. Let's go quickly to that of the velocity time graph here, okay. the slope will represent what? Your velocity time graph of the slope will represent what? Your acceleration, right? So you will see that this is acceleration, this is deceleration, this is again deceleration, okay, from here to here. I mean, here this is also what? Again acceleration in the opposite direction, right? In that way, this area under the velocity time graph will represent what? The distance covered during this time interval from 0 to 8 hours, okay, in the journey. And similarly here also it will represent the distance time graph in the opposite direction between 8 hours to 13 hours, okay. So this will give you what is the velocity time graph and what are the significance, what are the importance, what can be obtained from the velocity time graph, okay. Yes, let's go to that of the velocity time graph, different velocity time graph, okay. Now for a stationary object, the velocity time graph will be like this. A straight line AB represents the velocity time graph for an object at rest, okay. Now at rest means what? Velocity of the object will remain same. When the body is stationary, the velocity time graph, if the velocity will be 0, okay, velocity will be 0, then the graph of this will come down here if the velocity is going to be 0, okay. But this graph is not a velocity time graph for a stationary object. If the object is stationary, then what happened? The speed of the object will be equal to 0, or the velocity of the object will be equal to 0. In that case, what happened? If the graph is drawn for that of the stationary object, I mean the velocity time graph, then it will be here like this. Got it? Parallel to the time axis. I mean, I cannot draw it nicely as I'm drawing with the screen onto the screen, okay. But if the graph is coming up here as AB like this, this is for that of what? Uniform speed. If suppose this is your V, okay, meter per second, then what happen? At different time also the body remains same with that same V meter per second at this time. During this time also the body will move with the same velocity. At this time also the body will move with the same velocity. At this time also the body moves with the same velocity. That means throughout the time, okay, if the body moves with the same speed, then we said that that object is moving with what? Uniform motion. So if the graph is for that of uniform motion, then the graph would have been just like this, AB. Got it? But if it is a stationary object, then the velocity time graph for a stationary object, the graph AB would have been come down onto this time axis. Got it? Yes. Now for such, what happened? Acceleration of the body will be equal to 0 in the case of that of your uniform acceleration, or for that of the stationary object also, okay. When the body is moving with constant acceleration, okay, constant acceleration means what? Your acceleration will remain same. It doesn't mean that velocity is constant, okay. If the velocity of the object is moving like this, say I will give you a practical example, okay. Now let's take it that this is the velocity at the very beginning 0, and let's take it that this is V and this is time. So at the very beginning, what happened? It moves with a V equal to 0 meter per second, and this is in terms of second, and this V is in terms of meter per second, okay. Now if the velocity increases, okay, to 2 meter per second during 1 second, and for every 1 second, if the velocity increases by equal amount, so it will be 4 in 2 seconds, in this 3 seconds it will be what? 6, in this 4 seconds if it is 8, like this. So your change in velocity during this time, so final velocity minus initial velocity, 2 minus 0 is 2 divided by 1 minus 0 is 1. So your acceleration will be 2 divided by 1. Am I right? and from here to here the final velocity is 4, initial velocity is 2, 4 minus 2 is 2, time duration 2 minus 1, that is also again 2 by 1. So your acceleration is equal to 2 meter per second square. Your acceleration is coming out to be 2 meter per second square, like that. So for each and every of these time duration, the acceleration comes out to be constant, 2 meter per second, 2 meter per second square, like that, right? 2 meter per second square, like that. Got it? So what happened? Accelerations keep on same, that means constant. We said that that type of motion as constant acceleration. Velocity will keep on increasing by equal amount for every unit time. Got it? If that is of the motion of such constant acceleration, velocity will keep on increasing. That means at every time what happen, duration of this, somewhere here also at this time also the velocity will keep on increasing. Got it? So if that velocity keep on increasing, or rather with a constant acceleration, then the graph will be having a straight line with positive slope with the x-axis. Now this slope will give you nothing but again the acceleration. Okay, with that constant acceleration, as I have given you 2 for each of this time duration, acceleration comes out to be constant, right? That constant acceleration can be obtained by knowing the slope of this graph, right? So as I told you, that slope of the curve will give you the acceleration. Okay, now this is just like the comparison of that distance time graph for two objects. Okay, it is also the comparison of two objects A and B. Okay, from these two objects, I mean the velocity time graph of these two objects, we can easily compare it. So your object B will be moving with more acceleration than that of object A. It is also given here. Okay, when the object is retarding, that means when the body is moving with a negative what acceleration, okay, uniformly it is decreasing its velocity with equal amount. If it is decreasing, then the graph would have been a straight line like this with a what, with a positive with a negative slope. As I told you that the angle between this graph and the x-axis, we call it that as slope. If this angle is obtuse, then tangent of that obtuse angle, okay, more than what, 90 degree, this will always give you what, your negative quantity. And this negative quantity of this slope of this tangent of this angle, we call it that as slope. So if your slope comes out to be what, negative, so we say that that is negative what, acceleration, because slope gives you nothing but the acceleration. Got it? So negative acceleration, we simply call it as what, retardation. So if the object is retarding with a uniform amount, then it will be a straight line with what, negative slope. Got it? This is for of the increasing acceleration or positive acceleration. See, the graph will be curved upward. Okay, the graph will be curved upward, and in this case what happened, your instantaneous acceleration, as I told you in the case of that of displacement, if you want to find out instantaneous velocity, or I mean instantaneous acceleration, then we need to take a point here. Let's take it as t. Okay, and you need to draw a tangent onto this curve like this, a curve. And if you can find out the slope of this curve, then that slope will give you the instantaneous acceleration of that moving object at this particular time. Got it? As I told you in the case of that distance time graph, you can easily find out the slope of this by knowing the angle that is formed by this tangent with the x-axis. Okay, if you know this theta, then tangent of that theta can be obtained as the slope, rather that is the instantaneous acceleration. And if you want to find out from the graph itself without knowing the theta, then you can easily find out the time here. Let's take it a time as t final here and here as t initial, this time I mean, and this time t final. Likewise, you can also find out the velocity here as vf here. Okay, for this it will be 0, so your acceleration will be equal to what at this particular moment t. Then you can find out vf minus 0. Why? Because your initial velocity is 0 here, so your time duration is tf minus ti, like that. Okay, and if you find out this, then what happen, you can easily find out the instantaneous acceleration, or rather instantaneous acceleration, you need to take it that this instantaneous acceleration, okay, you need to take this as what vf, you take it as vf, no doubt, but this change in this time tf minus ti, you can simply take it as delta t. So you can also write it like this: your limit of this vf by delta t when delta t tends to 0. If this delta t time duration, if you keep on decreasing, okay, then what happen, you will get the acceleration at this particular moment. Got it? If you try to decrease down the time duration, then what happen, the time duration will be very short. Still, if you make it shorter, then the time duration will be very short. So if the time duration, if this time duration delta t tends to 0, then you will get it the particular acceleration at that moment. Okay, delta at that moment t, you can say. Got it? So likewise, you can easily find out the instantaneous acceleration by taking simply the slope of that tangent drawn. Okay, when I said tangent and when I said tan of theta, that tangent and tan of theta is different. When I said tangent, that is the line, okay, that is drawn with this curve, with having a common point, only a common point, at a common point. When I say tangent of an angle, that tangent means that is a trigonometric ratio tan theta. Okay. Let's see, when a body is moving with decreasing acceleration, that means retardation, okay, then the graph would have been like this curve. Okay, it will not be curved upward, rather it will be curved downward. So in such case also, you can find out at that particular moment, you can find that you can draw a tangent, and the tangent that is making with the x-axis, if you find out that tangent, and the slope of that tangent will give you the instantaneous acceleration at that moment, similar to that previous one. Okay, it is the same thing, right? Next, now as we have talked about the instantaneous acceleration, if we are going to find out the average velocity, then average velocity is defined as what? Average velocity is defined as the change in the position or displacement, okay, delta x divided by displacement. Rather, this is nothing but this is the average velocity, means what? Change in velocity divided by the time duration. Change in distance, change in time. Got it? So that average velocity is denoted by v var. Got it? V var. And so this change in distance denoted by dx, change in time, or rather time duration, is denoted by dt, delta t. Okay, so in this curve, suppose if you are having that of the what, positive acceleration, then what happen, your distance time graph will be drawn like this. This is a distance time graph. Okay, now let me little bit zoom in. Okay, now if I'm going to draw it, then this distance time graph, then the graph would have been just like this, curve upward. Okay, right? If you are going to find out the average velocity between these two time duration 5 and 7, for example, okay, then what happened, you need to drop a perpendicular from that particular graph onto the time axis 5, okay, and from that of the graph to that of the 7 second. So your time duration is 5 to 7 second. So your delta t will be what? Your delta t will be, final time is 5, initial time is 5. So 5 minus 7, it will be what? 2 seconds. So during this time of 2 seconds, if you want to find out the average velocity, then what happened? You need to find out the change in distance. From this graph, you draw perpendicular onto the y-axis, and this is nothing but this is the distance time graph. So what happened? The change in distance will be what? This will be what? 25 in the graph. Okay, 25, rather this is 27.4 the graph is showing, and here it is what? 10. So your change in distance will be what? Your final distance is what? 27.4 minus initial distance is what? 10, like this. Got it? So this distance divided by time means what? 10 by 7 minus 5, and this will be what? Delta t, and this will be denoted as what? Average speed. So average speed is denoted by V bar, not arrow. Okay, V bar represents what? Average velocity, and it will be given as change in distance divided by change in time during that time duration. Okay, so just like that, in the case of average what? Speed also, the total time that is covered, the total time during which the object moves, that will be in the denominator, and in the numerator the total path length will be in the numerator. So total distance covered, you can say, divided by total time duration, that will give you the average speed. Got it? Yes, that can be done from here. Now let's go to about that instantaneous velocity and instantaneous speed. I'm repeating again for the sake of your understanding. Okay, now as I told you that instantaneous speed means what? That particular speed of a moving object at that particular instant. So we know that this dx by dt will give you the speed. So your dx by dt will give you nothing but this as the speed. Okay, change in what? Distance to the change in the time duration. We call it that as what? The speed. If you want to find out that instantaneous speed, then this time duration should be made very small. Suppose if you are taking that time duration very long one from here, from this on the graph, you take it 2 points P1 and P2. Okay, and if you drop down that perpendicular onto the x-axis, then it comes out to be from 3 seconds to 5 seconds. So the difference in time, that means final time minus initial time, that means 5 minus 3, that is 2 seconds. Okay, and you need to find out what is the speed, the distance. It will come out from here, say from here to here, that is the distance moved during this time 2 seconds. Now you try to narrow down or decrease down this time duration. 2 seconds is a very huge time, okay, very long time. So you try to come down smaller and smaller, so that if you try to take 2 points, okay, which is little bit closer to this particular point 4, we are going to find out the instantaneous velocity at this time 4 seconds. Okay, then what happened? You take it another 2 points which is little bit closer, that means Q1 and Q2. So Q1 comes out to be at 3.5, and this Q2 comes out to be at 4.5. So if you take this time duration 4.5 minus 3.5, then it comes out to be only what? 1 second, right? 1 second. So if you keep on decreasing this time duration, then you will get it at that moment 4. So that is drawn, written in a mathematical form as what? V is equal to what? Limit of delta x by delta t. Delta x is nothing but this is the delta x, and this is delta t. Okay, time duration and distance covered. Okay, delta x by delta t, when delta t time duration tends to 0. Okay, if you try to keep this delta t decreasing so that it comes out to be very small, then we say that delta t tends to 0. delta t tends to 0, we write it like this: delta t tends to 0 with an arrow. Then what happened? We simply write that the limit of delta x by delta t when delta t tends to 0 as the differentiation of x with respect to time t, or you can simply call it differential coefficient of x with respect to t. So then you can easily find out that instantaneous velocity by taking the differential coefficient of that distance covered, okay, with respect to time. So we can easily find out from the graph the instantaneous velocity, okay, in this method. Okay, yes. Now this is, let's go quickly about the acceleration time graph. This is the acceleration time graph, okay, and the graph is what shown here with a along y-axis and time along x-axis. Why? Because time is independent and acceleration depends on time. Got it? So if this acceleration time graph is a straight line, then what happened? We can easily find out what from here. We can easily find out the velocity or the speed. So the area under the graph of acceleration and time will give you the velocity of that object during that interval of time. Got it? And if your body is stationary, then your acceleration time graph will be equal to what? Graph parallel to what? The x-axis, and it will be on the x-axis. You will see the graph, the red line, it is onto the x-axis. Okay, when the body is moving with uniform motion means what? Velocity will remain same. Okay, final velocity, initial velocity will remain same. In that case also it is same as that of the previous graph. That means acceleration is equal to 0 in that case. So acceleration equal to 0 means what? It will be along the x-axis. Okay, when a body is moving with a constant acceleration, okay, constant acceleration means what? Velocity will keep on increasing, but that increase rate of velocity will remain same. Okay, if that is there, then your acceleration time graph would be a straight line, okay, parallel to the time axis, not onto the time axis now, but it will be having a definite value. That definite value will be depicted by this point onto the y-axis. What is that? Uniform acceleration can be obtained from the graph. Okay, yes. So that is all about this for today's class. Thank you.